Hey, welcome back to the part 2 of our lesson 11.3, find the area of polygons. I broke it up into two different videos because this part is a little bit extra long, so I wanted to break it up to two videos, but it's also a little bit separate from what we've done before because we're going to be finding area in a different kind of way than just punching in just any old thing. There's going to be a little bit more math involved and recall from chapter 9. If you don't remember what chapter 9 had, it had SOHCAHTOA, so that will come back to bite us a little bit here, but we are going to do our best to solve these problems using our previous knowledge of right triangles. Okay, so what we have here is we got a pentagon, example 3, using area of regular polygon. We need to find that. Well, that's what we're going to find. We're going to find the area of the polygon here using our formula that we talked about in the other video in the upper right hand corner. That's going to be helpful for us. Let's try this one out. All right, so we have the apothem here, so we can start using our formula. Area equals, right, I'm using this, 1/2 or 0.5 times the apothem. Looks like our apothem, remember, is this, 9. But we don't have any of the sides. Right? We need to find out what this side length is in order to punch that into our next, part. We need to multiply that by the perimeter right here. How are we going to do that? Here's what we need to do. We can create a right triangle, right? We can create a right triangle and then figure out what the central angle is. What is that? Well, if you look at the whole thing, right? If I go around the whole circle here, that's 360, right? The whole circle. Well, a pentagon is separated into 5 different parts. So what we can do using this first step here is divide 360 by the number of sides we have. So 360 divided by 5, that's going to get you 72. This will be important later. Okay, so 72 degrees is, is this part, this whole thing right here, right? So we just need, not that, we need this right here. So let's just cut it in half. That's our second step, cut in half. So that's going to be 36, right, degrees. Okay, so let me erase some of this so that's less confusing. All right, so this is 36 right here, 36 degrees. Okay, we know this is 9, right? The apothem right here is 9. We have 36, and now we need this. This looks like a SOHCAHTOA problem. Look, opposite, adjacent. Oh, opposite adjacent. Which one's that? SOHCAHTOA. OA. That's a tangent. So let's use SOHCAHTOA tangent of 36 degrees equals the opposite. Well, we don't know the opposite, so that's going to be x. We know the adjacent, that's 9. And now we can solve for what that side is. Cool. And we're just talking about this side right here. Okay. So notice that real quick. All right. So let's solve this for x. 9 times tangent 36 equals x. Multiply that together in your calculator. Okay. You should get 6.539, somewhere close to that. But we just found this, right? So we need not just that part, but the other part. And we said that the apothem cuts the side in half. So what we need to do is multiply this by 2 to get the whole side. Okay, so multiply that by 2, you get 13.078. That's what each of the sides is going to be. 13.078. 13.07, 13.07, all these sides, right? They're all the same because it's a regular polygon. Okay, so if we're going to find the perimeter, we need to multiply this by, how many sides does the pentagon have? 5, right? That's how we're going to find the perimeter. So once you punch that in the calculator, 5 times 13.078, you get, oh, I need to do that in my calculator. 13.078 times 5. I got 65.39. All right. So that's our perimeter. And now we can solve this for the area. Nice. Did all that. I got 294.25 unit. Oh, it says feet. Feet squared. Woohoo! You can see why this process took a little bit longer, but as long as you follow these steps, right? These steps are pretty helpful to help you solve. That's what's going to be your key. All right, let's keep going. Uh-oh, we have a hexagon. We can do it. Let's use the same steps to help us solve. So we have the area equals, you can look on your sheet there to find the formula again. Oops, sorry. Area equals 1/2 times the apothem. Looks like it's 20 in this situation, right? Because it creates the right angle. Times the perimeter. We run into the same situation. We don't have the perimeter. So we're going to have to use that same idea. Make your right triangle. Okay. We have the whole thing, right? Find the central. Okay, so sorry. Let's use the steps. Find the central angle using 360 divided by n. All right, so the central angle, that's this right here, right? 360 divided by, oh, not 2. How many sides does this shape have? Looks like it's 6. 1, 2, 3, 4, 5, 6. Great. That's 60. Cut it in half, right? That's 30. Ooh, anyone see what you have here? I'm gonna erase some of this so it's a little easier to see. And you see what we got? 30, 60, 90, right? Oh, we can use some shortcuts here. We don't even have to use sine, cosine, tangent because we know this is 20. This is x. This is 2x. Now, we don't need the 2x part, but we know that this part's x rad 3. So if we remember chapter 9, we know we can divide by radical 3 to get us here. So divide 20 by radical 3, and we found our side. We found our x. Once you do that, you get 11.547. Okay, but we need both of them, right? This whole side, we only found part of it. So we're going to multiply this by 2 to get the whole side. Okay, I got 23.094. Nice. Okay, but we have just one side. We need to find all of them. So we have 1, 2, 3, 4, 5, 6. So if you wanted to finish your formula up here, we have 20. Oop, my bad. I said 20 and I wrote a 3. That's kind of funny. 23.094 times, how many sides are there? Well, 6, because it's a hexagon. Now we punch this in the calculator and find our answer. I got 1,385.64 centimeters squared. Moving on. Find the central angle using, here we go. Let's keep doing it. Notice what we have here, though. Okay, we don't have an apothem anymore. We have I don't know. Let's see. If we drew the circle again, it's not an apothem. It should be a radius. So that's going to change our, not too much. It won't change too much. It'll just change our process just a little bit. Let's see. So we have, keep doing the same formula. Area equals 1/2 times the apothem. We don't have the apothem this time, right? So A for apothem, and then times the perimeter. We don't have that either. Oh, man, this is not good. Yeah, we'll find them. No worries. So first up, let's create an apothem of our own. Okay. Hexagon, we just found out that this was 30 and this was 60. We did that in the other problem. If you're confused about how we found those, either do this first step again or just look at the last problem. It's the same thing. It's the same shape. Okay, so 30, 60, 90 again. Oh, this was x rad 3. Oh, which is the apothem. This is x, right? This is 2x. All right. So this is 2x. We want to get to x. We just have to divide by 2. So divide 6 by 2, and you'll have part of the side. So that's 3. Oh, making our life easy, which means this whole thing should be 6. Right? This side right here should be 6 because I just doubled the 3. Okay, but we still need to find the apothem there. All right, so we need to multiply this x by rad 3. So our x was 3. So we need to multiply by rad 3. So our apothem should be then 3 rad 3. And now I just need to find the perimeter, which should be 6 times, well, how many sides are there? 1, 2, 3, 4, 5, 6. 6. 6 times how many sides there are in the polygon? 6. And now punch in a calculator and find our answer. I would do this 12 times and then punch it in your calculator 3 rad 3. And then I'd multiply whatever that is by 0.5. That would be the process I'd like physically type in on your calculator. That way you get the right answer. Sometimes using certain numbers first, it gets you to different places. So 12 times 3 times radical 3 times 0.5. That's what I do. And I got 93.53 yards squared. Yeah, don't forget that. I don't know if I forgot another one. Let's see. Nope, we're good. Yep. Sweet. Last one. Best one. If you go on try on your own, you should probably pause the video and try it on your own. But let's see what we got. We have a square, which means this is 90, right? And if we're doing that same radius idea, we know that this actually is going to be 45 and 45. Hey, 45, 45, 90. Now, if you're confused about how I found that, you could just do that first step again, right? 360 divided by how many sides are there? 4. Then you get 90, but we cut this, right, central angle in half. So you divide this by 2 and you get 45. And that's what it says, cut it in half. You're done. So 45, that's how I found all that. I'm going to erase this so it's less confusing. Oh, I want that 45 though. If we have a 45, 45, 90, that means this is x rad 2, and this is x, this is x. If I can draw an x, right? So now if we're using that same idea that we did before, we can just divide this by radical 2 and get our x, right? Which looks like is not only just going to get us our apothem, but is also going to be part of our sides. So let's do that. 10 divided by radical 2. That's going to get you 7.07, which is also going to be our apothem. So if we're going to go back over and use our formula, we're going to have area equals 1/2 or 0.5 times, times our apothem we just said was 7.07 times the perimeter. Well, we have this. We need it doubled, right? So we're going to multiply this by 2. I got 14.14, something close to that. So that's this whole thing right here. So I'm going to do 14.14 times, how many sides are there? 1, 2, 3, 4. Multiply by 4. Put it all in your calculator. Here's our final answer. Last problem. I got 200 exactly. Woo-hoo. Good luck. Have fun. Of course, I know you're going to do great.